Welcome back everyone. In this lecture I will actually complete the proof of this isomorphism theorem that we were doing in the last class. So, let us recall what we were doing earlier. Okay. So, we started with two root systems which are irreducible root system comes from the pairs G H and then G dash H dash. Okay. So, from this you have this root system phi and then from this you have this root system phi dash. So, both are assumed to be irreducible root systems. So, that means G and G dash both are assumed to be simple Lie algebras. So, that is G dash or simple Lie algebras. So, then what we assumed? We assumed that there is a isomorphism from this phi to phi dash. So, which is given which is induced from the isomorphism on the Euclidean spaces. Okay. So, from this we wanted to prove G must be isomorphic to G dash. So, for this purpose what we actually realized. So, from this isomorphism of root systems we immediately got isomorphism of this corresponding Cartan subalgebras or the maximal toral subalgebras. Okay. So, we called that isomorphism as pi, okay, which is isomorphism on H to H dash by identifying H naturally with H star and then identifying H dash with the H dash star via respective Killing forms. Okay. So, we also fix bases inside phi and phi dash. So, let us say pi is the base inside phi, then we immediately observe that pi of pi, which is we denoted by pi dash, is base inside phi dash. And we have a natural map from alpha goes to alpha dash, from pi to pi dash, where alpha dash is given by pi of alpha. Okay. So, these are the things we had. So, now given this pi which is from H to H dash. Okay. So, this is already given. So, given for each alpha in pi. So, we have chosen x alpha inside G alpha and x dash alpha dash inside G alpha G dash alpha dash and define this isomorphism pi alpha from G alpha to G dash alpha dash. So, note that here alpha dash is just pi of alpha. Okay. So, now given these maps pi and then pi alpha where alpha in capital pi. So, we said that these maps can be extended uniquely to an isomorphism of Lie algebras. So, which we call it again pi from G to G dash. Okay. So, in order to prove that what we did, we indeed constructed this direct sum of this G and G dash and then we specifically defined one particular subalgebra of that. So, we wanted to prove this isomorphism. So, we actually realized that it is enough to prove that particular subalgebra is a proper subalgebra of this G direct sum G dash. Okay, that is where I stopped. So, let us prove that. So, you take this G direct sum G dash and then you define this subalgebra. So, note that this G direct sum G dash it is a semi simple Lie algebra. So, this is a semi simple Lie algebra with simple ideals, with only simple ideals actually G and G dash, and G is embedded in the first coordinate, G dash is embedded in the second coordinate. Okay. So, what is this D? So, this is defined to be you take the subalgebra generated by all these elements x alpha bar, where x alpha is a tuple x alpha x dash alpha dash as chosen before, and then y alpha bar. So, given x alpha, there exists unique y alpha inside G minus alpha such that bracket x alpha y alpha equal to h alpha, that we have seen already. So, that y alpha we take and then take y alpha bar, which is given by y alpha comma y dash alpha dash, and then you take h alpha bar to be h alpha comma h dash alpha dash. So, basically all this x alpha bar, y alpha bar and h alpha bar, so that generates this capital D for all alpha coming from pi. Okay. So, then in order to prove that there is an isomorphism from G to G dash, so which is actually given by, so you take the projection on this first coordinate and then restrict that projection from D to G, and similarly take the projection on the second coordinate, restrict that to capital D. Then we saw that these projections both are isomorphisms, okay, if D is proper inside G direction G dash. So, then using this we actually got isomorphism between G and G dash. Okay. So, that is the isomorphism that we were talking about in the last class. So, we proved this isomorphism modulo this in strict inclusion of D inside G direction G dash. So, let us prove this. This is again a little bit tricky. For that purpose, we have to use this maximal roots and then construct some subspace and then make it and then realize that this D will actually stabilize that subspace. Okay, what is that subspace? So, before defining the subspace, let us fix some notation. So, we choose this beta to be the maximal root. Okay. So, choose beta inside phi. So, this is the maximal root inside phi of phi. So, then it is clear that if you take the image of beta inside phi dash, so call it beta dash. So, this must be maximal root of phi dash. Okay. So, then what you do? You take some x inside non-zero x inside G beta and then non-zero x dash inside this G dash beta dash. Then using this we can define this subspace capital M. What is this? This is the subspace of this G direction G dash. So, that is spanned by the following elements. So, this is spanned by the following elements. So, you take add y alpha 1 bar composition etcetera composition, add y alpha m bar and then applied on this x bar. Okay. So, you take all these possible elements where this alpha I, they are all coming from of course pi and the respectively alpha I dash. So, that will be pi of alpha I. So, that will come from pi dash. Okay. So, you take all these elements, just span them and then that will define subspace of this G direction G dash. So, now it is not hard to see using the definition of y alpha. So, y alpha bar you remember this is nothing but the pair y alpha and y alpha dash y dash alpha dash, where alpha dash is nothing but pi of alpha. So, this is the definition of this y alpha bar. So, in particularly if you take this element and then look at where this element will lie. So, this element is actually going to be exactly, so you apply y alpha 1 and so on y alpha m on x. So, this will be the first coordinate. The second coordinate will be y dash alpha 1 dash etcetera y dash alpha m dash, apply it on x dash. So, this will be the second coordinate. So, then it is easy to see this first coordinate element lies inside G. So, this is beta. So, beta minus alpha 1 plus etcetera plus alpha m. Similarly, the second coordinate element that is lying inside G beta dash G dash beta dash minus alpha 1 dash plus etcetera plus alpha dash m. So, that means if you apply this add of y alpha 1 bar etcetera add y alpha m bar. So, then the respective these elements the first coordinate and second coordinate elements, they lie inside these root spaces which are strictly smaller than the root spaces beta and beta dash. Okay. So, then this implies immediately that if you take m intersection with g beta direct sum g dash beta dash g dash beta dash. So, what is the meaning of that? So, this is basically you take this g beta comma 0 direct sum g dash beta dash comma 0 comma g dash beta dash. Okay. So, all combination of this. So, sum of these two. So, this is going to be only one dimensional. Okay. This intersection is going to be just one dimensional. So, the dimension of this is going to be just 1, because this contains exactly that x bar inside. So, this is spanned by this m intersection g beta direct sum g dash beta dash is actually spanned by x bar. So, that means m must be proper subspace of g g dash, because if you look at this space, this has dimension 2. Okay. So, but now inside m, so this intersection has just only one dimensional. So, that means m must be proper subspace of this. So, now it is not hard to actually check D actually stabilizes m. Okay. So, that is something you can check. So, maybe I will check, it is not a problem. Okay. So, what we want to climb, so here is the climb. So, D stabilizes capital M. So, what is the meaning of that? Stabilizing means, so if you take some, let us say z inside D and some m in capital M. So, then if you take z comma m, the bracket, that must lie inside M. Okay. So, that is the meaning of stabilizing. So, in case D is equal to g direct sum g dash. So, then you can see that this, since D stabilizes m, so m must be ideal inside g direct sum g dash. So, that is m is on ideal inside g direct sum g dash. But we know that from the theory of semi-simple Lie algebras. So, this g, the first coordinate g and then the second coordinate g dash, they are the only ideals inside g direct sum g dash. So, what I mean by that, you take x comma 0 where x is coming from g. So, this is one ideal, and then 0 comma y where y is coming from g dash. So, these are the only ideals. Okay. These are the only ideals of g direct sum g dash. So, this is something we know from the semi-simple Lie algebras theory. So, that proves that this m must be either one of them. Okay. This is, let us say g again, this is, let us say g dash, then this has to be either g or this has to be g dash, but both gives contradiction, as you can see x bar, which is nothing but x comma x dash, where x is coming from g beta, x dash is coming from g dash beta dash. Okay. So, from this you can see that this for projection of x bar on any either coordinates are non-zero. Okay. X is non-zero and x dash is non-zero. So, that tells you that M cannot be G as well as G dash. So, that leads to contradiction. Okay. So, that contradiction we got because we assume that D is G direct sum G dash. So, that proves that D is indeed proper inside G direct sum G dash. So, it is actually ingenious proof. So, we constructed some subalgebra of G direct sum G dash that looks like diagonal embedding of G inside G direct sum G. To prove this D is proper, we constructed actually a module of D. Okay. So, we constructed a subspace of this G direct sum G dash, that is capital M. If you think about it, D stabilizes M means M is actually a module of D. Okay. So, since M is being module of D, if D is G direct sum G dash, then that would imply that M is an ideal inside G direct sum G dash. So, using that we just got contradiction. Okay. This is really a very interesting proof. So, now to complete the proof, so we need to only check D actually stabilizes. So, D stabilizes capital M. So, to prove D stabilizes capital M, recall the definition of D as well as capital M. So, that will definitely help. So, D is nothing but subalgebra generated by X alpha bar, Y alpha bar and H alpha bar, where alpha coming from pi. Recall, X alpha bar is nothing but X alpha comma X dash alpha dash, where alpha dash is pi of alpha, sorry, that coming from this pi of alpha. And similarly, Y alpha bar is nothing but Y alpha comma Y dash alpha dash, and then H alpha bar is H alpha dash alpha dash. So, now what is M? So, M is span of all these elements, add Z1 composition etc. composition, add Zs applied on Y, sorry, that is not the definition, it is span of all, add Y alpha 1 bar composition etc. composition, add Y alpha M bar applied on this X bar, where X bar is X comma X dash, where X is coming from G beta and then X dash is coming from G dash beta dash. Both beta and beta dash, they are maximal roots in the respective root systems. And then you take this where these alpha i's, they are all coming from pi. Okay. So, now to say that D stabilizes M, so it is enough to say that X alpha bar, Y alpha bar and H alpha bar, they all stabilizes M, because D is generated by all these elements. Note that X alpha bar comma Y alpha bar, so this bracket is nothing but H alpha bar. So, it is enough to say X alpha bar and Y alpha bar, both of them stabilizes capital M. Okay. So, it is not hard to see Y alpha bar actually stabilizes, because if you take Y alpha bar, then what will be Y alpha bar applied on some element of M. So, then you can see that this will be just the sum of Y alpha bar applied on this, add Y alpha 1 bar composition etc., add Y alpha M bar applied on X bar. So, which is nothing but again of the form add Y of alpha bar composition etc. composition, okay, add Y alpha 1 bar composition etc. composition, add Y alpha M bar applied on X bar. So, this is of the same form as this. So, which spans capital M. So, this element is in capital M. So, that means this element is actually in capital M. So, Y alpha bar stabilizes capital M is easy to see. Okay. So, that part is okay, and x alpha bar y alpha bar stabilizes implies h alpha bar stabilizes. So, these two are fine. So, only thing we need to check x alpha bar actually stabilizes. So, now look at x alpha bar and then see what happens. So, if you take again to say that capital M stabilizes, then it is enough to say if you take this particular spanning element and then if you apply x alpha bar on that, and then it can be written as again sum of the same types of the spanning elements, then we are done. Okay. So, that is what we will do. So, we take this add y alpha 1 bar composition etcetera composition add y alpha m bar applied on x bar, and then you take this and then take x alpha bar on this. Okay. So, note that this x alpha bar is nothing but x alpha comma x dash alpha dash, where alpha is coming from pi. Okay. So, if you take x alpha and then if you compute the bracket with y beta, so then this is going to be 0 for all beta not equal to alpha and beta coming from pi. Why? Because beta minus alpha is not a root for all alpha beta in in pi such that alpha not equal to beta. Okay. This is something we already know, because difference of two simple root, distinct simple root is never root. Okay. So, that means x alpha commutes with y beta for all beta not equal to alpha. So, it does not commute with only y alpha, but we know that what happens when you apply x alpha on y alpha. So, then bracket x alpha y alpha is just exactly h alpha. So, these informations we know. So, let us use this information here, then you can see that this can be written as x alpha bracket y alpha 1 etcetera bracket y alpha m x comma. So, this is the first coordinate, the second coordinate is x alpha dash and then y alpha 1 dash etcetera y alpha m dash x bar. So, this is the second coordinate. So, it is okay to work with only the first coordinate, because second coordinate calculations are similar. So, now look at this x alpha bracket y alpha 1 etcetera y alpha m applied on x. Okay. So, now you can see that this x alpha will pass through all y alpha i's except whenever alpha I is equal to x alpha. So, otherwise just passes through. Okay. So, in particularly you can see that this can be written as exactly equal to y alpha 1 etcetera. Let us say first time it hits exactly that alpha I. Okay. So, up to this you have y alpha m x. Okay. So, that then it is enough to look at this part and then do the calculation. Then you can see that if you take this x alpha and then y alpha I, this bracket y alpha m x. So, this can be written as where alpha I is equal to alpha, that is what we have assumed. So, this is you can see. So, this will be bracket y alpha I plus 1 etcetera. Okay, this you can call it some z. So, then this is going to give us bracket x alpha y alpha I bracket z. So, then using Jacobi identity you can see that. So, since alpha I equal to alpha, so then you get x alpha y alpha bracket z plus y alpha bracket x alpha z. So, this is what you get. So, now what is this first part, that is h alpha z plus bracket y alpha and then this x alpha z. Okay. Either this x alpha again passes through all the y alpha j's that appear inside z. Again every time whenever you hit y alpha, again you can use this Jacobi identity and then you can rewrite what we did before. Okay. So, then you can see that this by induction on the the number of y alphas involved in this Z, you can assume this element is inside M. So, the induction should start with just not having any y alphas. In that case, you can see that x alpha bracket x will appear, because let us say x alpha passes through all the way and then reaches x. Okay, that is where the induction should start. Then you can see that this is going to be 0 as beta plus alpha is not a root. Okay. So, since x alpha stabilizes x, so because bracket x alpha x is 0, now by induction on this M, you can conclude that this element is in M. Now, since y alpha already stabilizes capital M, you can see that this will be inside capital M, and since already we proved that x alpha stabilizes and y alpha stabilizes, then that implies h alpha stabilizes, or again use the induction on this M to say that this h alpha also stabilizes. So, that way we get actually this term that we have is actually inside the first coordinate of capital M. Okay, basically this is inside first coordinate of some element of capital M. Okay. And similarly, same kind of argument is used for the second term as well. Okay. So, if it passes through all the way, then it will commute with x bar. Otherwise, you just use this Jacobi identity and then rewrite this the way we rewrote, and then use induction, and then convince that yourself this will be just a combination of elements from capital M. Okay. So, this indeed proves this capital M actually stabilized by capital D. Okay. So, now this completes our proof. Okay. So, let me just summarize what we did. So, we wanted to prove that given isomorphism on this root system is indeed gives you isomorphism on the respective Lie algebras, okay, where phi is coming from the pair G H, and then phi dash is coming from the pair G dash H dash. Okay. So, we want to say this implies some isomorphism on G and then G dash. So, for that purpose what we did, we started with this pi, and then we actually extended this pi to isomorphism between H and H dash by identifying H with its dual and H dash with the dual with respect to the respective Killing forms. So, then we have chosen some isomorphism between G alpha and then G dash alpha dash, because both of them are one dimensional for each alpha in pi, and then using these maps we actually constructed isomorphism between G to G dash. The way we did, we first constructed this semi-simple Lie algebra G direct G dash, and then we actually define appropriate subalgebra of this G direct G dash, which we called it capital D, which duplicates this diagonal embedding of G inside G direct G dash, G direct G. And then we proved that this D must be proper by saying that D naturally acts on this subspace capital M. Okay. G stabilizes a subspace capital M which is neither G or G dash. Okay. So, that way we actually proved that D must be proper. And then using this we actually looked at the projection P1 restricted on D from D to G, and then P2 restricted on D from capital D to G dash. We proved that both must be isomorphism, and using this isomorphism we actually got isomorphism from G to G dash. which if you think about it, which maps x alpha to x dash alpha dash, and then y alpha to y dash alpha dash, and as well as h alpha to h dash alpha dash. So, basically this map is induced from the pi that we have here and pi alpha here. Okay, so, this proves the injectivity of phi that already we defined. Okay. So, that means for given semi-simple algebra, okay, the possible root systems can be the one that we listed already. Okay. So, for given root system, we still need to construct the semi-simple algebra corresponding to that. Okay. So, we, as I promised, I will only do it for the classical algebra. Maybe I will outline how to do abstractly how to construct this semi-simple algebra from given root system. Okay. Again, I can't give much details. So, I will only just outline bit how to get that. Okay. So, I will do that in the next class. I will stop here. Thanks. Thank you very much.